So in this video we'll be looking at the practical aspect of the feature engineering concept. In one of my previous videos I had explained the steps which will be involved in feature engineering. That particular video dealt with all the theory which was explained. So in this particular video we'll be looking at how we'll be implementing that in Python, and also this particular problem statement is one from the Kaggle competition. So basically the problem statement was to predict the price of the flight, that is the flight price prediction. Here we will not be exactly applying any model or doing any prediction. We will just be we'll be applying those feature engineering concepts over here, so that in the future maybe we can apply some model to this particular data set. Okay. So in the earlier video we had already covered all the steps that will be involved, and let's just begin here. That the first step which was there mentioned was knowledge of the basic libraries, that is pandas, numpy, matplotlib. So the first step in feature engineering is obviously importing all those modules, right? All those libraries over here. That is the first thing which I have done here. Okay, just a quick thing. I have, to reduce time, I already have typed everything and executed it here, so that it will be easy for me to sort of explain everything one by one. What I would recommend everyone here listening is to maybe write this as you watch this video, so that it will help you understand what are the things being done. So it will make you it will make you very clear about what is happening. Right, so the first thing I said here was basically we need to import all the libraries that we have done, and then here comes the dataset. So it is important here that in any Kaggle competition or any hackathon in general, you will be given two kind of dataset. You will be given the training dataset and the testing dataset. So the first thing you would require to do is to concatenate both of them or merge both of them into one. So your training and testing dataset should become one dataset, and from that particular dataset you can start doing your exploratory data analysis and feature engineering. So that is what I've done here. So as I said in the earlier video, it is important that you have a decent knowledge of all the libraries. So once you have the libraries knowledge, it will be easy for you to use the functionality of it. So immediately to read a dataset, you're going to use the pandas function, that is read Excel. So this was an Excel file. It could also be a CSV file, or it could be a Parquet file. So all you need to do is just change the name here from read Excel to read CSV and so on. So the dataset will be, the link of the dataset or the dataset will be provided to you either via the WhatsApp group or in the description of this particular video, right? So here what we have done basically is we have created a variable, that is train_df, and we are reading the train dataset, right? And then what we have done is we have used the head function. So the first thing you would do, or after importing libraries, is basically EDA. So you will start exploring your data. You will check about what are the different columns I have, what are the different rows, what are the different attributes, and what kind of exploratory data analysis you can do will start from here, right? So we have used the head function, which will return the first 5 rows. Just gives you a basic idea about what you're dealing with here. The next thing I have done here is I have created another variable called df_test, which basically what it does is it reads again the test dataset. So again we have used the read_excel pandas function, which will read the particular Excel file. Then again I've used the head function, which will again return the first 5 rows of the test dataset. So again, just for you to understand what you're dealing with, you will be using the head function. One more thing is, obviously you can change the parameter and mention maybe 10 or 20, and it will return you those 10-20 rows, and that is one basic concept of the head function. Again, so the next thing what I have done here is I have concatenated both the training and testing dataset. As I said before, whenever you get a competition problem statement or any hackathon, you will be given training and testing dataset, and what you need to do is concatenate them to make it into one. So what I have done here basically is I have created another variable which is called final_df, and what it does is it has concatenated both the training and testing dataset, right? So the first thing, you imported the libraries, Secondly, you imported your data set using pandas. The third thing what you have done is, since you had training and testing data set, you concatenated them into one, and then what I have done is you have again used the head function. So now this is the final data frame or data set I have, and whatever feature engineering or EDI I will be doing is to this particular data set, right? So then again I've used the head function over here to again check the first 5 rows and get a brief idea about what you're dealing with, right? So this kind of 7 to 8 cells of your notebook will remain same throughout for any problem statement in general. This is the first thing you'll be doing or dealing with. Then I have used the tail function, again one more functionality of the pandas, which will return you the last 5 rows. So again you can see what are the different columns I have, and what are the different parameters I am dealing with here. So immediately you come to know about one thing is that you're dealing with some NaN values. So it is important to note that whenever you apply any machine learning model, you have to make sure that none of your data set, or there is no value in your data set which is NaN, not a number. You cannot have such a value over here. Either these values have to be removed, or we have to replace them with some suitable value, right? So that I think we'll be doing as this notebook goes on. I will be showing what I have done here, and it will be easy for you to understand also. The next thing I have done is I have used the info function. So what I would suggest you to is just start making note, right? What are the functions which I have used over here? So first I have used the head function, the concat function, then I have used the read underscore CXL or read underscore whatever format your file is in. So if you start noting down these functionalities which have been used, it will be easy for you to sort of apply them anywhere or for any data set, because these will remain constant throughout. So again, the info functionality, what it does is it will return you the column name, the name of the columns, and also it will return you the data type of each particular column, whether it is a string. So here string will be denoted with object, and your floating value or integer value will be as like float 64 or int 32 and so on. So that will be the data type, and it also mentions the non-null count. So through this you can also come to know that if I have any null values, so here I think the price column has some null values which we need to deal with, right? So this is the basic thing which you will be doing first. So these things will remain constant throughout, so you can actually practice these steps on any data set. Okay, now from here we have started the feature engineering process. So immediately once you look at this data set, there is one thing you can do is date of journey. It has let me just check the data type which is mentioned. The date of journey is an object data type. So what I can do here is I can actually extract the date separately, the month separately, and the year separately. So you will be wondering why should I do this? So that is the thing, right? Any data analyst, the job of any data analyst is to start extracting and asking questions from the data set. So one thing you can ask is, is there any relation between the month and the price? There could be, right? Usually the peak season would be around November, December, winter, where the new year is upon us. So is there any relation there where maybe the month of December has higher prices, and so on and so forth? So the first thing I saw was, okay, airline is fine. Then the next column is date of journey. So the first thing that struck my mind was, can I extract the day and the month and the year separately? Yeah, you can do that. So this is where your feature engineering starts. So you are starting to extract some features from the existing features, right? So what I have done is I have created I'm going to create another column which will be date, then month and year. So instead of having all these three values in one column, we are going to separate them into three different columns, right? So what I have done is I have used the split function. So basically what this will do is, I am using the date of journey column, which is here, date of journey. I am going to split it at this backslash. So whenever we encounter a backslash, so this will be basically creating a list. So the 0th index of the list will be 6, then followed by a backslash. So then it will split it over there. Basically it will split the values wherever it encounters a backslash. So one value will be 6, one value will be 06, and the last value will be 2019. So now since it is a list, I can access any list using index value. So what I have done is the 0th index will have the day, the first index will have the month, and the second index will have the year. So that is what I have done. Simple. It's just what I just said in English. You just needed to write the same thing as a code. So I have created 3 variables. I have then extracted the date of journey, or I mean the date, the month and year using the split function, and then to the split function, as we know it returns a list, we have used the index to access that particular value. So once we do that, to check everything is going in order, everything is fine, we again call the head function. Now once I call the head function, I can clearly see that there are 3 new columns which has been created over here. Date column, month column and year column, and it is looking good. It's looking exactly how I needed it to be. So the day here was 24 and it is 24. The month is 03, the third month, it is proper here. The year was 2019 and the year here is also 2019. So once I get this, again I have checked the info function to check the data type so that it is not contradicting anywhere. It should be fine. Okay, now one thing you can do immediately is, okay, date, month and year, why does it need to be in object? I don't need it to be in object. It's all a numerical value. The problem which was creating over here was a slash. Now we have got rid of the slash. So once we have got rid of the slash, we can easily convert it into a numerical form since all of these are numbers. So I'm pretty sure the next thing is what I have done is I have converted the data type. Again, we have encountered another function. This function is, or this method is as type. So what I have basically done is, this is the date column and I have converted this date as an integer type. So final underscore df of date is equal to final underscore df date dot as type integer. So I have converted this as a type integer and I am storing it back to the date column. And the same thing I have done here is also, here also I have done the same thing. Basically month I have converted into an integer, then year also I have converted into an integer, and then all these values are storing in the respective column. Now again you have to use the info function. Your info function is like a best friend. In Python, in exploratory data analysis or in feature engineering, this is your best friend. You will be again and again checking this and making sure that everything is going right. So immediately my date, my month and my year, they have all been converted into integer from object. So everything is going according to plan. What feature engineering says, extract as much feature as possible from existing features if it helps you or it makes sense in your data set. Second, convert all the categorical features into numerical features. We have already started this process. We have converted the date of journey to a numerical value. As you can see, the date, month and year all have been converted to numerical value. Now, there's no need of this date of journey. I have already extracted the day, the month and the year, so I can drop the date of journey since I already have it as 3 separate columns. That is done easily. Again, you have encountered another function, so you can again write it down. What is this? This is the drop function. What I have done is final underscore df is my data frame and I've used the drop function and I'm passing the parameter column equal to date of journey. As simple as it sounds, it is very easy. You just need to use common sense. You're dropping, you have to use the drop function. Final underscore df drop, and again you have to mention which column you need to drop. That particular column you can mention as a list. Here I have mentioned it as a list. Some people use some other ways. They just mention the name of the column. I think even you can do that. Not sure about that. But since you might need in other data set, you might need to drop more columns. So it is easy if you use a list. So if you want to drop another column, all you need to do is just put a comma and then mention the other name of the column. It is as easy. It's very simple. Then again, axis is equal to 1 is because I want to through the rows. Axis is equal to 1 is basically that. And in place is equal to true. What this does is, okay, in place is equal to true is it will reassign the value back. So what this basically does is, as you can see over here, like here I have again assigned the value back to final underscore df. To avoid that, I have done here, I have put this in place is equal to true. If you people are getting confused, what you can do is you can remove this in place equal to true, and you can just put final underscore df equal to. So this will again, what it will do is reassign that. It will drop that column and then store it again back in final underscore df, right? To avoid that, I have done in place is equal to true. So I will keep it as it is over here. So it's another functionality or another parameter which you have come to know, so you can note it down. Again, to make sure everything is going right, you will use the head function. So after I check the head function, everything is fine, I don't need to worry. This is your second best friend. So you will be using this head and info again and again and again to make sure that you're doing everything correct. You don't want to mess up anything. We have gone through 16 cells, and it's very easy. This particular dataset is very easy. It is beginner friendly. So if you understand this, I think you will come to know what are the steps, and it is basically following some sequence and which you can apply as a formula anywhere to any dataset, right? The next thing what I have done here is final underscore df arrival time dot split. Okay, so what I have done is, again I have split the arrival time into two halves, basically the minute and the hour. So what hour and at what minute, that is what it has basically done. So this is nothing but, this is again feature engineering. You are extracting another feature from an existing feature, right? So this particular video I am focusing purely on feature engineering and not considering any aspect of ML. So maybe this, what I have done here may not matter as much while predicting my price value, but to make you understand about feature engineering, I have done this so that you understand how the split function work. As we've used it before, again I've used it so that you come to know, it becomes very clear for you. Excuse me. Again what I've done is final underscore df dot head. Again, as I said, head is your best friend. You have again made sure that everything is fine. Now the thing which I was talking to you before was the null, checking if any null value is there. You can see that the root has one null value and price has 2671 null values, right? So this is the third step that will involve in feature engineering, and that is checking about the null values. So this is another functionality which you have come across now, and you can make a note of it. That is null dot sum. You can also run is null, but it's just useless, right? You need to know how many totally they are there. So the sum function, what it will do is sum up all the NaNs and it will give you the output over here like this, right? Again, what I have done is this is again extracting as feature engineering. With the way we did it for departure time, I think, no, arrival time. Okay, this is the same thing which I have done here, arrival hour, arrival minute, extracting another two features from existing feature, and then again using the head function to see everything is going according to plan. Yes, it is going according to plan, right? So next thing what I have done is, again from the info function we also come to know that this arrival time and everything is an object. As I said clearly, we do not need any object value, we need numerical values. These numerical values can be either integer value or float value. So what I have done here again is I have converted that arrival hour and minute, which were initially object, to integer value using the as type function, right? So again, as type, important thing, please make a note of this. This is also one important functionality which we'll be using again and again. Again, dot info, your best friend, he is called again, he or she, and you can clearly see that it has some objects are still there, but we are slowly increasing the integer count also. The arrival minute, arrival hour converted to integer, year is converted to integer, month, the date, and the price obviously was integer and it remained as a float. Now the next thing what we need to do is slowly convert all this which are there into a numerical value. Okay, since we have separated the arrival into arrival hour and arrival minute, we have dropped the arrival time column, which is useless now since we already have it more clearly in hours and minutes. So again the same thing, dot drop columns equal to arrival time. As I mentioned earlier, you have mentioned the name of the column as a list, axis is equal to 1, and then in place is equal to true. Now I think very clear what in place is equal to true does. It will make it, or it will make changes into the original data frame. You don't need to assign it back again to final underscore tf. Again calling the head function, the second best friend, and checking everything is fine. Yeah, everything looks fine, no problem here. So as we did for the arrival time, we are going to do the same thing for departure time as well. Departure hour and departure minute. So we can extract another two features from existing feature. Again dot split at this colon over here. So as in our original data set it was in colon, so we have done the same thing here. You can see here 22 colon 20. So the 0th index will have 22 and the first index will have 20 value. So again we have created two new departure hour, departure minute, and then what I have done is again call the head function to check what I have applied is working correctly or not. Once I apply the head function, everything looks fine. We have departure hour, departure minute, arrival hour, arrival minute. Again, this is like a sequence, like a formula. You're continuing the same thing. Okay, now once you did the same thing for arrival, you're doing the same thing for departure. You have converted those object, it was in object the departure, you have converted it to integer using hash type int. So departure hour, again you have reassigned it back to that particular column itself, hash type int and hash type int for hour and minute. Again, once you have the departure in hour and minute, you don't need the departure column now, departure time column. You can drop it peacefully. You don't need to worry about anything. So again we have used the dot drop functionality. We have passed the columns equal to departure time in a list. As I said earlier, if you want to drop more than one column, all you need to do is put a comma and then add them like something, maybe like duration, right? So this will drop the duration column as well. And again what you have done is axis equal to 1 and in place equal to true. Instead of writing again final underscore df equal to final underscore df dot drop, we have just mentioned in place is equal to true, so that it saves your time. Again we have used the head function to check whatever we have done is applied correctly or not. So once I check here, okay, everything looks fine. Duration, total stops, additional price, date, month, year, arrival hour, arrival minute, departure hour, departure minute. Now again you call your best friend, that is your info function, and there you go. The number of numerical values are just increasing. That is a good sign. What you're doing is correct. You have to be happy, right? So integer 4, but there are some still object value. We will slowly do them now, one step at a time, right? So this is the template which you need to follow. The categorical features, convert them to numerical. In order to do that, do I need to extract any features? Do them if necessary. But at the end of the day, this is just feature engineering and this is not applying any model. Once you apply a model, you might feel, okay, this what I have extracted is actually doesn't make any sense to my model, or is not helping it improve its accuracy. Then you don't need to do anything. You can just drop it that time. But to make sure you're doing everything correctly, it's better you extract features, do conversion of numerical to categorical, right? I said the opposite. It should be categorical to numerical. So the next thing what I've done is the total stops. So this total stops is an object value, although it necessarily need not be an object value, right? It can be a numerical. Stops in general are always either 1 stop, 2 stop, 3 stops. So whenever you think of stop, you think of some numerical value. But in this case, it is an object value because of this non-stop, right? Instead of non-stop, can we have it 0? So to check that, what we have done is we have used the dot unique functionality. So again, this is another functionality which you can make a note of, is the unique functionality. So what unique functionality does is it will return you the unique values which are present in that particular column. So data frame, name of the column, df, in the list form, name of the column, and dot unique functionality. What it basically does is it will return the unique values which are present in that particular column. So in our total stops column, the unique values present are non-stop, 2 stops, 1 stop, 3 stops, NaN value and a 4 stop value. So what we have done is we have also included the value cons. The value cons is nothing but it will give you how many values are present for that particular attribute, right? So one stop 7056, non-stop 4340 values, two stops 1899, three stops 56, and four stops 2. So it makes sense. It is fine. It's nothing to worry. The next thing what we have done is we have we have used the map functionality. So we are mapping these values to a numerical value. The easier way to do this is this only, just converting that since we have only 4 features, one stop, non-stop, two stop, three stop, and 4 stops. What we have basically done is we are mapping that 4 stops to just a numerical value 4, 3 stops to just a numerical value 3. Because of the word stops, this particular column turned out to be an object value. So to solve this particular problem, what we have done is use the map function. Final underscore df total stops is equal to final underscore df total stops dot map. So you're mapping the non-stop value to 0, the one stop value to just a numerical 1, a two stop value to a numerical value 2, and a three stop to a numerical value 3, and a four stop to a numerical value 4. And then the null value which was there. So the thing, see, we clearly came to know that null values are very less in the total stop. If you scroll back, or if you go back to the video and saw the is null dot sum, we came to know that there were I think it was single digit null value. So what I have done is we have just replaced the null value, and this is another functionality, that is fill NA. Just a second, let me go back down. I went 2 down. Let me just check where were we. We were near the map functionality. Yeah, over here. So you have replaced the nan with fill NA, right? Fill NA, what it does is it will just replace the NA value with whatever value which you are passing. So here what we have done is we have filled it with 1, because 1 is the most frequent, right? It is the most appearing number here, so I have just replaced it with 1. Since why, you'll be wondering why am I doing this, is just a common sense kind of an approach. One stop has a maximum number of output, right? One stop has 7056 value. So what the first thing you will do is you will just put 7056 one stop, so we replace it with 1. At the end, when you apply any model, maybe if your accuracy is less, maybe these are the small things you can play around and see if maybe I change this to some other value, does it help me increase my accuracy? That will come later once you apply any model. For now, time being, we will use the common sense and simple approach here. That is, we have just replaced it to the most occurring value. So great, we have also dealt with NA values here and we have filled it. Again, we call the second best friend, that is the head function, to check everything is in order. Everything looks fine over here. And again, you have called the info function to see everything, or look at the data types and non-null values. Great, everything looks fine. And integer 32, 32, 32, float, object, float. What we have done is total stops, and once we check total stops here, yeah, there you go. Total stops has now been converted into a float, which was an object. It got converted into a float because we have replaced this non-stop with 0. 0 becomes a numerical value, so these have been replaced with numerical value. The next thing what I have done is we are checking if there is any null value still in the total stops. No, there is no null value. So this is another trick or functionality which you can use to, it will just return the the rows which have null values. So we are using final underscore df total stops dot is null, and we are finding that we are putting that in a data frame. So we have created a data frame of the data frame total stops dot is null. So clearly it says that there is nothing, so you don't need to worry, there is no null value over here. Okay, now what we have done is we have dropped the root column over here. You will be wondering why I have dropped the root column. It's purely because we already have the source and destination. So if we have the source and destination and we also have the total stops, the root in between should not matter to us, right? While making a prediction, it should not matter. We know ultimately are going from point A to point B. And we also have the feature which says the total stops, how many stops you're making from, or how many stops you're encountering while reaching from point A to point B. So what I've done is I've decided to drop the root column, and this is unnecessary some special character here which will cause a problem. You can't even convert it into a numerical value. So what I've done is I've dropped that particular column, in place is equal to true. Now I think it's very clear. Again and again, instead of writing or reassigning it back, I've used the in place is equal to true. Now the next thing what I've done is, again, your second best friend, that is the head function, and to check everything is fine, I have dropped the root. It should not happen, or it should not happen a case where something goes wrong. So nothing has gone wrong till now, everything looks fine. So yeah, I think let's move on here. Right now, again, if you check the info function over here, now we have very few object data type. We have airline, we have the source, we have the destination, we have duration, and additional info. That's all. Now we have come to additional info. What does this additional info have? So to identify that, we have used the unique count. Right. So what this unique count does is, as we know, it will return the unique values. What are the unique values which are present in that particular column is done by the dot unique. So okay, what are the unique values which are present here is no info, in-flight meal not included, some angry customer did not get his meal, no check-in baggage is included, one short layover, no info, one long layover, change airports, business class, red-eye flight, two long layovers. So these are some things which are present here, and maybe I would have thought of what to do. Then again, info function, as I said. Okay, now what I have done is this duration. This duration is, whenever I say duration, it is 60 minutes or 2 hours or 2 hours 50 minutes. Basically it is just it's a numerical value, either in hours or in minutes. So the problem, the root cause of this is this h, right? This h and m. What this does is, this is basically making nuisance here. It is converting into object because of this. So again, what I have done is I am separating them, the duration, into hours and minutes, as we have done earlier for arrival hour and arrival minute. Similarly, I have done here for duration hour and duration minute. So I have split in h. So once I split in h, this will be the 0th index and this will be the first index, right? So once I do that, again, what we are doing is we are checking the info functionality, right? We are checking the info functionality to check the data types and also to check everything looks fine, right? The duration r dot unique. So we're checking what are the unique duration are, and through this I come to know that that phi m is causing some problem to me. So let's see what I have done to fix this. You can just take a pause here and maybe just jot down some points, or just write few things which you have learned new, so that it helps you remember things. I think it's more than 20 minutes, so you can maybe pause and have a look at everything once and then again start. Okay, hope you had a look at everything before, and let's check. So we were over here. This phi m was causing a problem, so I immediately checked what are the values having this phi m. So then I came to know that, oh, what is this, right? So this is some problem here. The duration cannot be 5 minutes, right? Common sense, from Mumbai to Hyderabad cannot be 5 minutes. So then what I did was I checked the duration minute dot unique value to see what are the unique value I have. Then after that I came to know that there are some NaN values also. So to check that, what I have done is, if you remember earlier, what I have used the same logic over here. Final underscore df duration minute dot is null will return you all those columns or all those rows, not columns, which have the null values, and I'm passing to a data frame so that I can look at that. So here you can see that the duration minute, right? So these were null values, and it's causing a problem, and I'm pretty sure I have removed them, right? So by common sense you can come to know that Mumbai to Hyderabad is not going to be 5 minutes, so something was wrong. So I dropped those particular two values. So what I've done is final underscore df duration r should not be equal to 5 minutes. That I have assigned to final underscore df. So if it is equal to 5 minutes, it has been dropped. So that is also one way where you can drop the rows based on certain value. So I did not want any particular a column or row to have duration r with 5 minutes. So to do that, what I said, my df should have all those values which are not 5 minutes. So if it is equal to 5 minutes, it has been dropped. If it is not equal to 5 minutes, it has been reassigned back to final underscore df. Now once I again do the unique count, I come to know everything looks fine. I don't have any m or minute or anything. These are all the r's value and unique r's value. And also minute, there is no null value. Everything seems fine. So what I've done here is then I have converted the r's, which was a number category, which was in an object type, into a numerical type. Since now all values were in numbers, we have converted them into integers, right? So we use the as type functionality to convert them to integers. Now, basic math, the r value has been converted into minute. So I have done everything in minutes. So let's not have this confusion of hours and minutes. Let's have everything in one particular value. So in this particular case, what I have done is I have converted everything into minutes. So hours has been converted into minute. So I have just multiplied by 60. Now what I have done is I have checked here again, use the add function, and you can see that the duration r and duration minutes. So r has been converted to minutes. Just now we have done that into 60. So the next thing what we need to do is we can merge them, right? I don't think, I think I would have done that. Okay, so the minute, okay, not let's avoid confusion here. What I've basically done is we have the duration, we had separated the duration into hours and minutes. Okay, clear. Duration converted into hours and minutes. And then what we did was we converted the r into minutes. So now this r value is in minutes, and this minute value is obviously it's having in minute. So what we have done is this m is causing a problem here, right? Since the m is present here, this particular column will be object, but we come to know, or we clearly know, we do not want any object. So let's split this at m. So if I split this at m, the 0th index will be my minute value, and this is what I have basically done. I have split this at 0 and I would have assigned it back. Yeah, I split it in 0 and I have assigned it back. Now what will happen is, now that m is gone and you have only duration or duration minute, and again I'm checking for some values over here, checking if any null values are present. No null values are present. Okay, now this is one thing also here, that there might be a case where your duration is just in hours, right? Maybe Bangalore to Goa is just 1 hour duration. So the minute will be obviously 0, or it will be just a space. So what I have done is I have identified that there are some space values, and I have replaced those space values with 0, so that it's 0 minute basically. So if I add anything to 0, it will just be the value present in the r column, which is actually minute. Now to avoid all this confusion, first thing what I did, I don't think you people should be confused. It's very simple. Converted the hours, converted the duration into hours and minutes, converted the hours into minutes, converted the minutes or kept the minutes as it is. Then what I've done, convert the minute into integer. Now we know these were all in object, we have converted them to integer. Now the next thing what I have done is common sense. The hours were converted into minute and we have the minute. So we can just combine them into one and say just duration. So now your duration, if I add them, will be just in minutes, right? So it has done two things. One, it has made sure that the duration r and minutes has just been converted into one column. Second, we have again, what we have achieved is we have converted the category into numerical feature. So this is one good thing which has happened, is everything looks sorted now. We have only one duration and that duration is in minutes. It is better we have in minutes. And second thing is we can convert it back into the numerical value. So that is what I have done here. Duration r plus duration minute.
that will give you the total minutes of the duration of the flight. And I've created another basically column that is the final total duration time, which is duration hour plus duration minute. And then again what I've done is use the head functionality, your second best friend. So your second best friend, by applying that function, what I come to know is the data, the column which I've created, the duration total, it looks clean, it looks proper. Now what I can do is I can drop these particular columns, right? The duration hour and minute, since I have already one column is enough, that is duration total. So again, if you have noted down, like I said, or if you pause and look, you would have come to know the columns equal to how to use the drop functionality. Final underscore df dot drop. What we have done is we have dropped the columns duration hour and duration minute. As I was saying before, if you want to drop two columns, what you do is you pass a columns equal to parameter as a list, and you separate them with comma, and inside a basically the quotation mark you have the name of the column, and in place equal to true. Again, I'm reiterating the fact that the in place equal to true, what it does is it will make the changes back to the original data frame. You don't need to explicitly write final underscore df and assign it back, right? Okay. The next thing what I have done here is I have used the head functionality. Hello. So again we have used the head functionality. So what this head functionality does, we know it will return the first 5 rows, and again we are making sure the dropped columns do not appear somehow, right? We have dropped the duration hour, duration minute. So there is no duration hour, there is no duration minute, all we have is duration total, right? Everything is fine. The next thing what we have done, drop column duration. Okay, there was another duration column, if you remember, it is over here. We don't require that also. We have duration total, so let's drop that also. Basic, what I've done, drop columns equal to duration, in place equal to true. Again, now what I've done is I have again called the head function. Now just let's look at it one by one from this side. Duration total converted into integer, departure minute converted into integer, departure hour converted into an integer, arrival minute converted into integer, arrival hour converted into an integer, year is already an integer value, we know that, month is an integer value, the date is integer value, the price also is an integer value. We have to do something to additional info. Total stops converted into integer value. The only thing non-integer is the airline, the source, destination, and additional info basically. Now what we have done is airline.
Okay, now we are coming across one important concept that is called as encoding. Now the airline values, there are a lot of airline values, right? And we need to convert all these airline value to a numerical value. So now the basic thing or the most common thing which you do is do encoding. What this encoding basically does is it will convert the categorical feature into numerical feature. So these are the unique airline names of the airline, right? Indigo, Air India, Jet Airways, SpiceJet, so on. So what a label encoding will do is it will create a label for each of this airline. So maybe the label created for Indigo is 0. So wherever Indigo is there, that particular value will be replaced with 0. Wherever Air India is there, that particular value may be having a label 1, and that particular 1 will be showing up over here. So that is what in short label encoding will do. And to do label encoding, we are going to import another library. So we are going to use from Scikit-learn.preprocessing, you are going to import the label encoder, and you are assigning this label encoder as a variable, and you are calling this function label encoder function. Now what we are doing is airline, we are doing the same, we are doing label encoding. So we are passing the fit label encoder dot fit underscore transform. Basically what you don't need to memorize this code, you can copy paste it, maybe use this same code and maybe copy paste it in the future where you want to use. You can use the same concept, just the name of the column or the name of the data frame will change, and you can change it accordingly. So we clearly come to know what is the concept behind label encoding. It will create labels for each of the category and convert them into number. Now the same concept maybe I can apply for source and destination. So that is what I have done here. For every source and every destination, we have created labels. So maybe whenever you encounter Bangalore, maybe Bangalore will be converted into 1 and New Delhi may be converted into 2. So wherever New Delhi is present, that particular label will be 2, right? Whenever Bangalore is there, it will be replaced with 1. To achieve this, what came to know today is we use the concept of encoding, and that concept of encoding we are using or is done by this particular function or library. Label encoder is a function and the library is label encoder from Scikit-learn.preprocessing, right? Please make a note of this, that from Scikit-learn.preprocessing import label encoder, and we are assigning that to a variable, and we are converting the airline, the source, destination and the additional info, which are all categorical features, into numerical. So these are whenever you want to convert anything which is not possible through some simple method or through some basic math, we use the label encoding feature. So we have created the label encoder for all this. We are going to create labels and then change them. So that is what this code does. Simple final underscore df airline is equal to label encoder. Label encoder is this particular function dot fit underscore transform. It will fit those particular value, right? That airline will be fit into 0 and 1. Fit underscore transform which particular column? Airline column. Same way source, destination and then additional info. Now the next thing what I've done is I've called the shape function. So what the shape function does, another functionality you have come across today, you can make a note that it will give you return the number of rows and columns, right? So our data set has 13,352 rows and 14 columns. Now again I have called the head function. Now you can clearly see I don't have any categorical features. All my categorical features now hopefully have converted into numerical. You can see airline 3, source is 0, destination is 5. You don't need to worry. You clearly will come to know that all this source, destination, which were Bangalore, Delhi, have been converted into some values. And through this, what you have done is also again call your best friend. You can clearly see all categories have been converted into numerical feature, and that is almost the end of feature engineering. You have done almost everything that is required from you to do. You have all this data type converted from category into numerical. Observation: complete data pre-processing and feature engineering complete, as there exists no categorical variable. Thus this data set is now ready for model training. There's another question which will come to your mind is, this price column has so many null values, what to do with that? Now why I have not replaced this with is because ultimately that is your target variable, right? So I can't do anything to target variable. target variable is very essential for making some prediction or applying some model. In this particular video, we are not going to look at applying model and what I will do to that target variable. If this column was not price and some other column, then I would have definitely used the technique to replace them. The null values would have been replaced. So importantly, we know the three techniques to replace null value: mean, median and mode. What mean does is, if you have any numerical feature, the best way to replace null values in that will be the mean. If you have some categorical features, the best thing would be to use the mode of that particular column, right? So this completes the data pre-processing and feature engineering. There exists no categorical variable, and you can now actually apply models. So that is what I've tried to do over here, although I've not done anything, so it is giving error because I've not done or I've not applied any model over here. So in general, in short, to sum everything up, the more you practice, the more you will be confident in this. So ultimately the goal would be now to apply a model and see what sort of predictions we can try to make out of this. But in short, this video is basically covering all whatever I said in that theoretical video. This is just a practical aspect of that. We have looked at the various functions that we will require of the libraries. We also have completed all the category. We have converted the categorical features into numerical features. We have also done some EDA. We have checked. We have done some EDA. Most importantly, we extracted more features. Right? We came to know how to extract features, how we use the split functionality. We also came to know how to convert from different data types using the as type functionality. So there are a lot of new things which you have come across in this video, and what I would love for you to do is try to make a note of all the new features which you have come across, and maybe create a Word file and post it in the group, so that we can even I can come to know what are some of the things maybe you have understood, and what are the few things which maybe I might have missed and you might have realized along the way. So I hope things are very clear. If you have any doubts, please feel free to reach out to me. I am no master in this even I need a lot of practice, and I still am practicing it. So if you would want to work with me, or want to work on anything related to this, you can feel free to reach out to me, right? So thank you so much for listening to this. See you soon.